So we looked at last time at some the difference between traditional file processing and the database approach. Okay, and we said that for traditional file processing, each user needs to define and implement the files needed for specific software application. While in database approach, you don't have to define many files and to store data in different files with that is used by different applications. You can just use a repository place, single repository, where you store all your data there. Okay, and it is accessed by many users, and we have already explained that. In terms of the characteristics of the database approach, okay, it does have many characteristics. We started by looking at the first one, which is the self-describing nature of the database.
Dr. Sorry, we cannot see the slide.
Can you please, now?
We cannot see the slide.
Cannot see the slide. Okay, thank you. Okay, for the self-describing nature of the database, we said that by itself, the database, it does contain the definition and the structure and the constraint of the database itself. And all those, the structure of the database is stored in one separate place within the DBMS, which is called the metadata or database catalog. Okay, and it is used by the DBMS. Each time a user sends a query or wants to update, to do some update, the DBMS will look first at the database catalog, whether the input data is following the requirement and the constraint or not, in order just to look or update the database. And we looked also at the second characteristic of the database, which is insulation between programs and data. And we said that there is a separation between the program that is accessing the database and the data itself. Okay, and we gave an example. For instance, we gave an example for using different browsers to access the same database. Okay, many users will access or might access, for instance, Amazon.com database, and each user is using different program, is using different browser. One can use Google Chrome, another one can use Internet Explorer or Firefox or Brave, whatever the browser you are using. Here, the program that is used to access the data is different from, let's say, it can be different. Okay, if you want to change the data, for instance, let's say Amazon might change its data or the structure of its data or database, it doesn't have to send, let's say, a note to everyone who is using different types of browsers. Okay, the browser will deal with the data. You are searching for the data, that's all. Okay, you can use any type of programs, okay, as long as it does have connection with the database itself. So here it will not affect you. For instance, when you do have data and you want to change the structure of the data, it will not affect changing the program. It doesn't lead directly to you have to change the program. You can do whatever the data structure, you do the update on the data structure without being forced to change the program itself, which is accessing the data. This is known as a program data independence. In some other type of database, for instance, object-oriented programming, for instance, okay, what you do have, there is another thing, which is where you can define the data, the structure of the data itself. Okay, when you talk about structure of the data, you define the data itself. For instance, when we talk about as I mentioned, object-oriented, you are defining the data and the operations on the data itself. That means the data and the operations of the user can define the operations on the data, which will be part of the database definition. It is based on the catalog. Okay, in the first one, what we mentioned in the first one, we said that we do have the program, Okay, that is accessing the data and the data itself. This is the separation and dependent. In another type of database, okay, object-oriented database, what you will have, for instance, you will define, let me just, okay, for instance, in other types of object-oriented, what you can have the structure of the data, like for instance, in object-oriented, you have, okay, you have your data. Let's say, for instance, data type. And here you do have, for instance, you have operations, or let's call them methods, for instance. Okay. In Java, for instance, when you write an application or you write a method, okay, you might, for instance, says int, let's say calculate, okay, and I will, for instance, integer, I will provide my operation or my method with, for instance, x, y, for instance. Okay, these are the argument. Okay? You specify the argument in here in the data type. You specify the argument of those. Let me go back here. So I will just remove that x, y, and I will specify in this page or in this place. I will specify x and y. Okay, data type, for instance, of argument, where I will put int, x, and y. Okay, so in some types, or in this type of operation, this type of database, okay, where we do have the data type, the data type of the argument and the method. Here we talk about the operation, which is what we can do on on those, let's say, the operations or method or the small program or processes, for instance. Okay, here we do have separation between the operation or method, and you do have here we can have a list of operations. This is the second object oriented. Okay, this is an object oriented within your program, which have a list of argument or data types or data, and in the other part you define all the operations and methods. Okay, for instance, I do have car. Let's say a car, I can have within the car, I can have many operations: accelerate, brake, stop, whatever the method you are defining. As long as here what you want to do, we do have such a separation. If I want to change the structure of the data type, okay, I don't have to change the operations. Okay, they are separate. That's why we say in this case that we do have a program, data, operation, and dependence. That means it is separated. Okay, it is separated, and we are not forced when we want to change, for instance, one part. If I want to change the program and the operation, as we specify, the operation is made in two parts. You do have that the name and the data type that I have mentioned. It is known as interface, and you do have the implementation, which is those methods, those operations. And this way we say that we do have an independence between the program itself and the operation. This is another type. So you do have insulation between programs and data. We do have program data independence, and we do have program operation and dependence. And another thing, when we do have these two properties, okay, when we say I do have program operation and dependence and program data and dependence, these two are called, this is what is known as a data abstraction. So what is data abstraction? Data abstraction means we do have program data and dependence, and we allow to have a program operation and dependence. Okay, if we have this type of characteristic, we say that we do have data abstraction. This is definition of the data abstraction. Another property which is known as conceptual representation. Conceptual representation means we don't include in our database representation how the data is stored or how the operations are done. If we go back to one of our diagram, okay, if you can see this one, okay, we don't have details about let's say the implementation. What we know here so far, we know how we do have this time object or this product, this sales, and this store component, and this is the relation between this component and this and this and this. But we haven't got any information about the details, how this object time or product or sales or store, how they have been implemented, how what are the different types of data types that are part of this object or this or this or this. So this is what is known as conceptual. That means you are not aware about the details of uh, that data, how it is stored, or any method that has been used, how it is accessed. For instance, when you search in Google, you search for some keywords and you click search, okay, and directly you will get some results. In this, we are fetching, we are requesting to get some data without knowing, for instance, how the data type, how many data are in the Google database, what are their data type, how they have been stored, what are the different operations that have been done inside the Google, for instance, database or Amazon.com database. We don't care about such information. What we care is about how to get the data itself, how we can get that data. Okay, and this is what is known as conceptual representation. That means when you define conceptual representation through what is known as a data model, okay, we represent our conceptual database. Okay, we don't include, okay, the details of the data, and we don't include how the operations are run inside the database. This is what is known as conceptual representation, and this is what we mean by, let's say, conceptual data model. This is the model that we have used to represent a relationship between the different types of entities or component of your database, and we didn't specify, we didn't include in this diagram the details. It's like you do have a big picture. Okay, it's like you didn't zoom into this let's say into this diagram. You just looked at this the component of your database from perspective of what are the different types of components. Like when you are looking at from, let's say, from a high altitude to a house. Okay, you just look at the house and you see that the house has let's say 4 windows and 2 doors. This is what you look at from let's say from a high altitude, but you don't know, okay, what are the, let's say, how each door was made, in which material the doors or windows has been made, whether it is a wood or PVC or whatever. So you don't need to know such information. The only thing that you need to know is how many doors and how many windows. This is what is known as conceptual view of that house. And the same thing, if we say this is my database, okay, what I look at only to the component. I know that there are 4 components, and these are the relations between those components, and that's all. This is what is known as conceptual model. Now, how each component is made, what are the different parts of that component, it is not part of this conceptual model. Okay, it is just because it is a big picture without looking at the details of such data or database. Okay, Shabab, this is an example of the catalog, as we mentioned, okay, you do have a relation, for instance, and you specify for each relation name. When we talk a bit about relations, okay, we're going to see later in the coming chapters, we mean by table. Okay, in terms of database, relations is known as table. So we do have a relation table, relation student, or table student. It does have 4 columns. Grade report does have 3, section does have 5. And you go, for instance, to the details of the columns. I will say column name, I can have a name column. Okay, in name column, I do have, this is the data type, and it belongs to which relation. This belongs to student. Course name belongs to the course that is here, and so on. It is a catalog, it is a definition of, it is a metadata about the different part of your database. As we mentioned for the conceptual, we said that the conceptual, we don't care about how the data is stored. If we go and give an example, for instance, okay, let's say this is the storage. It shows us the storage of student record. For instance, name, the field name, okay, it starts at the position in the record itself at position 1, okay, and how many characters? It is 30 byte, for instance. A student number, it starts at position 31, which is after the name, okay, and it does have 4 byte. Now, in terms of as a user, when we use, let's say, for instance, PSU database or university database, we don't care about how these types of, how each field is stored within the database. It is not our job to know that, okay? The main usage of the database as a normal user is how to get the data, how to search within the database, okay? How the data is stored, it is not our concern, okay? It is the job of the guy or people who have designed and created that database, okay? This is what we mean by conceptual level. Another characteristic, Shabab, for the database approach is the support of multiple views of the data. When we talk about multiple views, which means how people conceive the data, how they are looking at the data, okay? What is a view? When we talk about a view, it is a subset of the database. When you look, for instance, when you look at, when you search within in Google, you are searching, let's say, database, for instance, tutorial, okay? What you will get only part of the database, because when you say Google has a huge database, you are not looking at all the data within that database. You are looking only on one part of the database. This is what we meant by a subset of the database. You are extracting only one part of the information. And the view, this is what you are looking, which is you are viewing. We call it view. And when we say view, it might contain, which is known as a virtual data. We say virtual data derived from the database file, but it is not explicitly stored. Does anyone has an idea, Shabab?
Yes, doctor. For example, when we search about any students has average above than 3, it will give me just some name of students, and it will not store them in a new database.
Now, what you are looking here, what you said, you are querying the data. Here we are talking about deriving.
Like, doctor, so it could be like, for example, Google search results. So not all the websites are stored in Google, but it gives you a link to access that website. So it gives you a reference to access a website which is stored elsewhere.
No, just think about something, some data that is extracted or concluded based on another stored data. That means, I will give you a clue. You do have some data within your database, and by looking at that data, you can extract another data. This is what is known as derived. مستخرجة. Derived معناه مستخرجة.
When you look at the absence sheet, for example,
Yes.
if the data counts how many students are there, you can derive how many students are absent.
Yes, you can have that, but more precisely, if I give you, for instance, if in the database, I will store the date of birth, okay? The year, month, day. What can you derive from this field, from this information?
The
For
age.
any
The
student, very close.
age of
You
the
can age,
person?
you will deduct the age, you will derive the age. And that age is not explicitly stored. It is not stored in the database. We didn't specify, we didn't create, like here, for instance, I didn't create a column, which I called it age, where I do have how many years or how many old that student is. What I will store date of birth, and through an operation, okay, you can implement any operation or methods within your database or the program that is accessing database. It just calculates, it just goes to the database, look at the date of birth, compare it with today's date, okay, do the operation, and it gives you, or it will display to your screen the age of that student. This is what is known as, that's what we said, it is a derived data. It is not explicitly, it is not stored. We didn't store the age. However, we stored the date of birth. And from the date of birth, we derived the age of that student.
Doctor,
Okay? Yes?
so we just use the date of birth that is stored in the database already in order to the age of all students, right?
Yeah, but the age is not stored. We didn't store, we didn't create a field within the database which is called age, and we put the age itself. No, we don't need it. We need just date of birth. By knowing the date of birth, I can tell you what age that old, how old is that student is, for instance. Okay, Shabab?
Here.
Okay. Now, also we do have multi-user DBMS. Okay, why here we are talking about views? We are talking about view because, as we mentioned, we said that the DBMS or the database approach, we do have a single repository where many users are accessing the data. This is what we mean by multi-user DBMS. That means, as we gave an example for the browsers, we said many users have different browsers. That means that those users are using a variety of distinct applications. They're using different types of application, okay? And sometimes each application might give you different types of information, okay? For instance, I might have someone who is interesting to the grades of the student, another application that is used only to get or to look at the financial situation of the student, and so on. And each one is a view, okay? Each user is looking at the data from different perspective based on what he needs to know about or what he needs to extract and get as data from the database. We do have another characteristic of the database approach, which is known as sharing of data and multi-user transaction processing. Sharing,
Doctor,
that means, yes?
sorry, before we move on, can you go back to the last slide? Yeah, so it says must provide facilities for defining multiple views. Can you explain this?
That means when you do have a DBMS, when you have database, when you are designing database, you need to make sure that with your DBMS, your developed DBMS should be able to provide different views for different user. Okay, we will not say that my database will display only one part of the database to this specific user, and if there is another user who wants to see another part of the database, you will say no, you cannot see that one. No, when we do have database of the user, okay, let's pick up the university database, and you do have the student table, okay, maybe the financial guy will look at only the finance part, okay, or the tuition fees or the payment from that student record. Another user, instructor, for instance, or management, will look at only one part which is related to the absence of that student. Another one will look at only to the transcript of that user. Here we can see that our database or our DBMS is allowing us to look at the data from different perspective, from different users. Different users are accessing the same database, but they are looking at the different data, even within the same student record. Yes?
Can a blockchain be considered as a database?
Say it again.
A blockchain, can that be considered as a database?
Yeah, but it is different. It's a type, another type of database. Here we are talking about, as we mentioned from beginning, what we are covering here in our course is a relational database, which is based on tables. When you talk about blockchain, it is distributed database, and even you don't have that metadata, so it is different types of database, which is chained. The one day database is chained to another database, and so on.
Okay, thank you for the answers.
You're welcome. You're welcome. Okay, another type, as we mentioned, the characteristic of the database approach is sharing, as we mentioned. Okay, sharing of the data, and we do have multi-user transaction. That means you allow, okay, in the database approach, it is possible for multiple users to access the same database at the same time, and this is a good thing. Okay, when you do have, for instance, if you pick up an airline reservation system, for instance, and you want to book a seat, let's say within any airline, okay, you do have maybe thousands of users or hundreds of users are trying to book the seat within the same flight of the same airlines, and there is no conflict. Okay, and this is all thing based on let's say the shared database, or the shared data within the database approach, because it allows us to have access to the database at the same time with many users, and there is no conflict. When I book, for instance, if there is one seat available within some specific flight, and there are many client or customers trying to book that same seat, there will be no conflict. It is based on the first come, first serve. If the first user who has access to that booking and managed to book that seat, even if you after a few seconds, or let's say just a few seconds, if there is someone who comes and wants to book the same seat, he cannot do that, because there is something what is known as concurrency control software. That means there will be within the DBMS, okay, within the DBMS there will be a program that will control that concurrency. That means when you do have many people trying to get the same thing, okay, if one of the first one who manages to get that thing, the others, automatically the software will update the data. And if there is another one who wants to get the same thing, he will be send message that there is no availability of such seat, for instance, or such item. Okay, and all this is done because of we do have that concurrent control software. That means you have to update the data automatically. The data is updated, which allow, because if we allowed multi-user to access the same data type, the same database, without having that concurrency control software, what will happen? You might, for instance, yes, we allowed 5 people to access the airline reservation system. All 5 customers have managed to buy the same ticket, or to buy a ticket with the same seat. And this is the problem. And they will go to the airport having the same seat number. Why? Because the system didn't update during, let's say, the buying process or transaction. The system didn't correctly update the database. No, because we are allowing multiple users to access the database at the same time, there should be something that will control the concurrency. And this is what is found in any DBMS, or any DBMS database management system. There is always that part, as if you remember what we said when we defined the DBMS, we said there are several programs that are working inside the database management system. And one of them, one of the processes or the software that is running inside the database is the concurrency control software that will control the multi-user and update the data accordingly. Clear, Shabab?
Yeah, and Doctor,
Yes.
Yes.
what is the solution the DBMS can do to solve concurrency when many users try to access the same data?
By updating the data. If you remember, I don't know if it did happen to you, for instance, sometimes you are looking at, you want to do reservation, you look at the, let's say, the airline website, you find that the seat is available, okay? And when you try, maybe you made some delay, you were thinking about when you saw the price of the seat, you were thinking about whether it is a correct price or not, and you decided to go ahead. You click the next. When it comes to the, let's say, to the payment, okay, the system will return an error saying sorry, the seat is not available, because someone at that time, okay, did manage to buy the same seat, okay, because maybe he did have say a fast access, a good bandwidth and good internet connection, and he was faster than you, and he manages to buy that ticket or that seat, for instance. Okay, the control concurrency software control system software will do the update, will ensure that the update is done properly and quickly, and it is done correctly.
So when the update is done correctly for him, and for example, the price exchange or anything done, they give me error message that you cannot do this.
Not an error message, but it will tell you this is the update of the database. Okay, you just you were looking at the seats available. You saw that there was one seat, for instance, and when because you met some delay when you processed, okay, someone has already bought that ticket. When you go to the buying the ticket, you pay for that seat. It will return that, because that the concurrency control software has updated the database, and when it comes to your turn to pay for that seat, it will return that there is no longer availability for that seat.
Clear.
Okay. Sharing of data and multi-user transaction. We continue with that one. We do have transaction. When we said transaction, that means you are doing some types of access to the database. For instance, you are updating the database. You are doing a transaction. You are executing some program or processes that involves one or more database. Any types of programs or processes that are running and that are involving one database or many databases, it is called as a transaction. And one of the properties of the transaction is what is known as isolation. Isolation means you can find many transactions that are running at the same time, and they are appearing like they are running in isolation. Like, for instance, like when you do have multi-threading or multi-processing, or you do have many operations or transactions, those transactions are running at the same time. Okay, they are providing, maybe they are working all together to provide an output, but from point of view of the database DBMS, they looks like they are separated transactions, like they are working separately. They are not related to each other, but in reality they are related to each other to provide the same, or to work within the same data. It's like you do have, for instance, I have to do, let's say you do have a big operation which involves multiplications, division, addition, for instance. Okay, and you will find maybe one process will do the addition, another process will do the division, the other process will do the addition, and at the end, okay, they will give you an output, because all those processes were working together to provide some specific output. And this is what is known as isolation property. That means whenever you do have transaction and you do have many transactions running at the same time within the DBMS, okay, and all the same, maybe they are working together, they belong to the same transaction, those processes, but they looks like they are isolated and they are working alone. Another the property which is atomicity. Here we talk about atomicity. That means either all the database operations that are in a transaction are executed or not. What is meant by that? Let's give an example of you are at an ATM machine. Okay, Shabab? And you inserted your bank card, or let's say your debit card. You entered your PIN number, for instance, and you started, you look at, let's say, the menu, and you clicked on withdraw money. Okay, you put, for instance, 100 riyal. Okay, and while you were waiting to get your 100 riyal, the system crashes. What happened? What do you think will happen, Shabab?
I think you should keep your 1,000 riyals.
When the system reboots and you access your account again, will you see that 100 riyal has been debited from your account or not?
Supposedly that it should not be withdrawn because you did not receive it.
You didn't receive it. This is what is meant by atomicity. That means when you start an operation on a database, okay, the database should make sure, or the DBMS should make sure that that operation is terminated. It will not consider any operation that is not, or any transaction that is not terminated because of some problems, okay, or some reasons, okay. It will not update the database unless the transaction is done totally. Okay, this is what I mean by when you start an operation, okay, you make sure that a transaction are executed or not. Executed, that means the whole transaction is done from the starting to the end. When you insert your card and you enter your PIN number, you choose to withdraw money until you get your 100 riyal. At that moment, we say that the transaction has finished and the database will be updated. If during the transaction something wrong happened, normally the DBMS will not update your database. This is what is known as atomicity property. It makes sure that when the transaction starts, it is fully executed or it is not executed. There is no in the middle, in between, half executed and half not executed. This is not a characteristic of a DBMS. Okay, having any transaction fully executed or zero execution, let's say 100 execution or 0% execution, this is what is known as atomicity. Clear, Shabab?
Yes.
Okay, we stop here. We continue, inshallah, for the next session. Any question, guys?